Hi, this is Michael King. Now we're going to look at an application of time value of money, which is calculating the value of loans. This is going to be in Chapter 5 by Booth, Clear, and Rikita, Section 5.7. A loan is actually an application of the annuity formula, which is why we studied it. If you assume you have a fixed interest rate, you simply calculate the loan payments using the annuity formula, where the payment itself is a type of annuity. Now, each payment in a loan is actually made up of both interest and principal. And when you start paying off a loan, initially you're paying more interest, but as you pay down the principal using that level payment each period, the interest will go down and the amount of principal you repay goes up. So we're going to calculate the amount of the loan payment using the annuity formula. But to calculate how much is interest and how much is principal, we're going to have to create what is called an amortization schedule, where the word amortize means to retire a loan over a given period by making regular payments. So let's look at an example. Assume you take out a 3-year loan of $10,000 and your quoted rate is 5% annually. What will be your payments, and calculate your amortization schedule? Okay, so the first step is going to be to draw the timeline. It's an annual payment, so there are 3 periods. We're going to set the loan, or the present value, equal to $10,000, and it has to be completely paid off by the end of the 3rd year, so the future value is going to be 0. Here you can see the present value. Here you see the future value. The question is, how much will the payments be? We need to make equal payments over the next 3 years to retire the debt, and we know that the interest rate is 5% on whatever balance is remaining at the start of each period. So let's use the annuity formula to figure out the payment. Here's the annuity formula. Notice that we plug in K equal to 5%. That's because a quoted rate of 5% payable annually and compounded once per year is the same as an effective rate of 5%. The number of periods N is the number of years, 3, and plugging the input $10,000 as the present value, we calculate that our equal payments are going to be $3,672. Putting it into our timeline, this is what it will look like. Notice that because we're making payments, we're going to put them in as negative because we're going to be reduced. It's money that is flowing out of our pocket. With this payment, we can now build the amortization schedule and figure out how much is going to be interest and how much is going to be principal out of each payment. So this is what your amortization schedule is going to look like, and it may look a little complicated, so let's take it piece by piece. First of all, you see that there are 3 periods because there are 3 years. Under column labeled 1, we have the beginning principal amount. It starts at $10,000. You can see that the loan amount is going down each year. In column 2, we have the payment that we're going to be making, which we just calculated with our annuity formula. You can see that it's $3,672 each period. In column 3, we have the amount of interest that we're going to pay, and what we're going to do is we're simply going to multiply our effective interest rate times the balance at the start of the period. Notice that in the first year, we have $10,000 outstanding, multiplied by 5%, so our initial payment interest is going to be $500. On the basis of this, we know that if we make an annuity payment of $3,672, then we must be repaying the difference between that annuity payment minus $500, or a principal amount. Notice that the principal amount in year 1 is going to be $3,172. So by the end of the first year, our loan of $10,000, subtracting that principal repayment, is going to be $6,827.91. Now this principal amount at the end of the first year becomes the starting amount at the beginning of year 2. So again, we take the beginning amount, which is now $6,800. We deduct our equal payment, which is $3,672. We can figure out how much the principal, the interest amount is by multiplying that starting principal amount of $6,800 by the 5%, or $341, which means that our principal repayment in that second year is going to be $3,330. Deducting that from the starting amount, we get that the end amount outstanding is $3,497. That becomes the principal amount outstanding at the start of the third year. Again, you can see the equal payment is going to be made up of interest and principal. You multiply that starting principal amount by 5%, we get that the interest in the third year is going to be $174.86. And the principal amount is going to be exactly the beginning amount outstanding, such that at the end of the third year, there is no balance, and our loan has been totally repaid. Now you may be wondering, okay, how much is going to be outstanding after 1 year? We can actually calculate this by either looking at our amortization schedule here and looking at the end of the first year, and we see that there is $6,827.91 outstanding. However, we could have also calculated it by looking at the value of an annuity. Now, instead of looking at it as an annuity with 3 years, we look at it as an ordinary annuity, because the payments come at the end of the year, with only 2 years remaining. So the number of years remaining is the number of periods, or n equals to 2. We still have our effective interest rate of 5%. We know that our payment is going to be $3,672, and we know that the future value has got to be 0. So we can solve for the present value using the annuity formula. Plugging it in, we can see, yes, the principal amount outstanding at the end of the first year is $6,827.91, or the same amount that was shown in our amortization table. So at any point in time, you can calculate how much is remaining by simply using this annuity formula and remembering that how many periods you still have outstanding.